So what we want to do is we want to talk about nuclear radiation and the processes that are happening in nuclear radiation. So first of all, I'm going to need to come up with a couple of elements. I'm going to say, first of all, here's my element A, and it is going to decay into element B. Okay. Now I need to come up with a couple of things. The first thing I'm going to do is I need the atomic mass number, which is referring to the number of nucleons. I'm just going to give it a value. Let's say 200. And then let's give a value for its atomic number, which is the number on the periodic table, which is equal to the number of protons. Considerably less than 200, so let's say about 50. Okay. Now, what I am coming into, my daughter particle that's coming out of this parent particle, tells me the type of radiation is. The first thing I look for is the nucleon count. Now, there are two things that could happen here. First, if the nucleon count doesn't change, that means that we have two types of radiation possible. One type will be beta, and mind you that there is beta minus and beta plus. Okay. The other thing that could happen is gamma, and gamma is just light coming off there. So if this number doesn't change, then it's either beta radiation or gamma radiation. Okay. If the number does change up there, it's going to change in really one way. So imagine, if you will, that my nucleon count goes from 200 and it goes down 4. So I'm left with 196 nucleons left. Okay? So that means that there are 4 nucleons that are kicking around somewhere. Okay? In addition, the other thing that we're going to look at is the electron number. Now, we had a first example that it didn't change here. So what we're going to do is we're going to look at what happens, okay, in both beta radiation and gamma radiation, and then let's look at what happens up here in this other type of radiation. Okay, so if this number remains the same, that means that the only product, in addition to this new element, is gamma radiation. Gamma radiation is radiation that's associated with a particle that isn't ejecting matter, but instead is ejecting light. Okay? The other possible way is this: if I had this nucleon number not change, but if my atomic number changes, and let's say it changes to 49, that means I have lost a proton, but in that process gained a neutron. Because if I went down by 1, that means my neutron had to go up by 1 in order for that to happen. So that means I've lost a charge. I lost that positive charge somewhere in my process, but I did not change the atomic or the mass number. Okay? So that means that I had a proton that turned into a neutron. And when that happens, that charge that is ejected from that proton comes out as a positron. A positively charged electron. It's antimatter, if you will. Okay? But every time there's beta radiation, there is a secondary particle that is also ejected, and that is referred to as a neutron. Or not a neutron, a neutrino. Jeez, McNeil. Not a neutron, a neutrino. And this neutrino is going to be of a type that is opposite of that electron. So this being a positron, the opposite of a positron is an electron. Okay? So that's the ejected particle of beta. Now here's another possibility that can happen. So imagine that this stays at 200, but this number doesn't go down by 1, but instead goes up by 1. That's my new particle. So that means somewhere in this process, I gained a positive charge. The only way that can happen is if my neutron loses a negative charge and gets turned into a proton. So it's ejecting a particle, and that particle that it's ejecting is of a negative charge, which is an electron. Okay? And once again, a secondary particle is also ejected called a neutrino. that neutrino is going to be of the opposite of this electron. So that neutrino would be a positron neutrino or an anti-electron neutrino. Both of them are the same thing. Now you might see this electron expressed a little bit differently. You might see the electron, let me find a space for that. Let's find a space right over here. We might see that electron expressed like this, E0, -1. That does not mean that this is a -1 proton. That does mean that it is carrying a charge of -1. Okay? It's a little bit confusing, but it's just simply the way we expressed it. And you can see because it doesn't have any nucleon number, it can't be a proton or a neutron. That 0 means that it's not a nucleon. Instead, it is a non-nucleonic particle, which makes it an electron or a neutrino. Cool? If I were to express the neutrino in this fashion, either neutrino would be 0, 0. They don't carry a charge, whether they're an antineutrino or a regular neutrino, and they are not a nucleon. Cool? Does that make sense?